Now for our presenters, first let me introduce Daniel. Daniel Muller. He is a member, or committee member actually, of the Electrical Engineers Group. He's also heavily involved with the Safety Engineers, Society for Safety Engineers, past president and still on the committee there. He's an electrical engineer. And the other presenter that we are lucky enough to have today is Geoff Hunt. Geoff's an electrical engineer as well, and is also involved in the electrical engineering group. And Geoff is currently a member of the Engineering New Zealand board. And that's probably the introductions over. And thank you very much. I will pass it over to you, Daniel.
Thank you, Martin. The purpose of this presentation and the lessons learned series is to learn from what happened in the past, so that we can build it into our designs for the future, so that we don't repeat those mistakes. Now, I just want to start off by saying I'm not an expert, and I won't be able to answer all your questions. Many of these events occurred before I immigrated to New Zealand, but fortunately, after speaking to one of the ministerial inquiries members by the name of Dr. Keith Turner, he referred me, or he mentioned that his student friend, Geoff Hunt, was actually the man behind the idea for the temporary power supply to Auckland. And through LinkedIn, I managed to contact Geoff, and then I realized it's the Geoff from Engineering New Zealand. And I was lucky enough that he offered to participate. Here, you've been a CEO position for 27 years. And I've mentioned that you had the idea of the solution, which we'll cover during the incidents. We're very dependent on electrical power in our daily lives. And if we lose power for a day or two, it's going to be quite difficult to cope with. But as we approach on our carbon zero future, we're going to become even more reliable on electrical power, and thinking of transportation and process heat and everything coming from electricity. Power failures will really severely impact on us. And so we've decided to look at some power failures. And the significant one, the most significant one, I think, was a 5 weeks power failure in 1998 in Auckland. And then several others followed that had an influence on especially the larger cities. And we haven't covered things that happened outside Auckland and Christchurch, but except for the supply and demand mismatch that affected the lower part of the North Island and up to Hamilton. And this photograph is from a local substation fire that I just added to brighten up our presentation. So let's go on to the 1998 Auckland power failure. And when things go wrong, it goes wrong really bad. So I'll hand over to Geoff for that presentation on that bit.
Okay, look, this wasn't the typical outage of a few hours or days in isolated areas following a storm. This was a 5-week outage in the CBD of New Zealand's largest city. It was actually an international embarrassment. So in this brief presentation, I wanted to talk about the failure, but I particularly want to talk about the response to the problem, because for me, the lessons learned can be applied in many crises. So the Transpower network, this is just to give you an idea of the network really supplying into the CBD. You can see at the top there, the Transpower Roskill and Penrose substations. And down the bottom, or in the middle, I should say, you can see the Vector or Mercury substations. And the two areas that we're interested in are the Liverpool substation in the centre and the Quay Street substation towards the right, and the cables that supplied those two substations, which you can see coming down from Transpower Roskill and Transpower Penrose. On the surface, it looks okay. Dual cables should have been okay. So moving to the next slide, though, just keeping in mind the nature of oil-filled and gas-filled cables. They're complex mechanical systems, and you can imagine that if there is overheating, there'll be expansion in the cable, and it's going to cause some twisting, and they tend to fail actually at the joints. And if you were on the case in the introductory slide, it did actually show you the screwed up nature of the cables at the joints. Going to the next slide, and on this slide, as I talk, you'll see the failures kind of coming up, and you can see the dates when the various cables actually became unserviceable. So it had been a hot, dry summer. The cables were heavily loaded, and they progressively failed in the order coming up over a number of days. There were attempts made to reliven two of the cables. They come up in yellow in a minute. There they go. But the recovery was only short-lived. And as I said, the actual failure mode turned out to be thermal expansion leading to mechanical failure at the joints. The subsequent inquiry was a little bit profound. Amongst other things, it found that some of the cables had not been properly installed originally. This related to the thermal conductivity of the soil around them. There was a gas leak with, I'm not sure if it's one or both of the cables, that had never been resolved. There was no asset management plan for the cables. The maintenance requirements were poorly specified, and the risk of failure was not understood at any level in Mercury. And it's possibly due to this last point that the planned cable tunnel from Penrose to the CBD had not made it to the Mercury board for approval. So this is really engineering failure at many levels. So my involvement started with this phone call, which I got on a Friday night while I was running a family barbecue, and one of the most memorable phone calls I've ever received. I was managing a company called Alstom at the time. We are the largest service provider to Transpower for transmission line, substation maintenance and construction, and the operation of the regional control centres. And that's why the operator at the regional control centre called me. So I went to bed that night wondering if Mercury would get the power back on by the next morning. And early next morning, the CBD was still in darkness, and I thought there was a high risk that the cables would not be reliable going forwards based on the way they had failed, and that a plan B was required. So I actually got out a road map and plotted a course for a 110,000 volt overhead transmission line from Penrose to Key Street, which is one of the blue markers up there near the top of the map, and made contact with the Mercury CEO and persuaded him that he should fund development of a proposal for a temporary overhead line. That was on a Saturday. On a Sunday, we had quite a big crew in Auckland, and by late Sunday or early Sunday morning, Monday morning, we actually had a fixed price proposal ready to go to Mercury to build a line. We'd brought Transpower into the picture, and they'd agreed to delay other projects to make materials available. It was interesting going into the Mercury building where the engineers who were trying to deal with the problem had clearly not had much sleep and weren't really seeing beyond the fact they thought they'd be able to get the cables back into service. And 4 days later, we signed a contract over a box of Kentucky Fried Chicken, would you believe it, to build this line over a 10-week period. About a week later, though, Mercury announced that the problems with the cables were much worse than I'd first thought, and that it would be at least 8 weeks before power could be restored. So the Alstom team reassembled and through the night and figured out how to build a line in 21 days. And ultimately, we did so in 18 days, including a tee-off to the Liverpool Street substation. Some of the cables never returned to service. Quite a profound time. And on the map here, you can see the Transpower substations in yellow. You can see the Vector or Mercury substations in blue. The dashed line, the dashed orange line, is actually the route that the cable tunnel has taken, and for about 2/3 of it, it was the route of the temporary transmission line. Daniel, next slide, or maybe even the slide after that. So just some quick key points from how do you recover from a crisis of this size. So first of all, you have to bring in the best organisations you can find, and for that, Alstom brought in Becker for the design, and for all the civil works, Hawkins Construction, and Alstom retained all the technical work associated with the line, substations, and overall project management. All the parties were brought together into Alstom's construction base, so the communication distance was across the corridor. And we had quite a big project management team. We were spending $500,000 a day on an 11-kilometre wide work front. So just scaling up to be able to do that is absolutely critical. And of course, it had to be a cost-plus contract to enable us to run at speed. The photo on the left there is in the innovation on the fly category. Our solution to getting from Newmarket through to the city under the ridge, the Parnell Ridge, was to use a disused rail tunnel and build an open wire transmission line through that 110,000 volts. It turns out to be the only place it had been done anywhere in the world, and we were a little worried when we livened the line for the first time. So there's a lot more to tell, but that sets the scene. The long-term solution, of course, as I'm sure you all know, was to build the tunnel from Penrose to Hobson Street. And that tunnel carries cables for Transpower and for Vector, and I expect telco providers as well. Just quickly, you can see the dotted dashed yellow line coming out of the Penrose substation and heading along actually underneath the motorway. And then there's a shot if you want to go and get down to the tunnel. One entry point is from the Penrose substation. And just finally, the route. So this is a very, very important piece of infrastructure for Auckland, and it's certainly beefed up the security of the network, the electricity network, no end.
Okay, so there was a fault in 2006 at the Otahuhu substation after severe weather. An earth wire dropped over the 220 kilovolt line and then fell on the 110 kilovolt bus bars below. 230,000 customers were affected, and the duration of the outage was 6 hours. And it was so bad that rail was disrupted. Radio transmitters had to be switched off, and there was partial hospital closures, and procedures had to be stopped. And the reason? Yeah, so there it is, the $25 shackle, which had failed and caused this embarrassment in the industry. I'm not sure which contractor was responsible for the maintenance of the Otahuhu substation at the time, but when it was Alstom, we had the never-ending issue of minor maintenance issues causing embarrassments. And eventually we adopted an accountability model which said for a particular manager, he was accountable for the maintenance of a number of substations, and in turn that was delegated down to supervisors who felt that they owned the substation, and if any failure occurred, it was reflected on them personally. That model worked really well and caused them to
really get into a mode of looking for all possible things that might cause an outage. And I would have liked to have thought if that model was operating, it may well have caught that. Just as a side note, some of you will have heard of Wayne Brown. He's standing for Mayor of Auckland, and this isn't a party political broadcast, but civil engineer. He saw this as this failure is reflective of insufficient engineering experience on the Transpower board, and persuaded the government that he should be appointed to the board, and indeed he was, and in turn he became chairman of the Transpower board. I don't know whether we can thank Wayne, but we haven't really had that many embarrassments going forwards of this nature.
Incidentally, that's after reading that book, that's how I became aware of the power failure in 1998, and then started asking questions. And we'll discuss that under the lessons learned. So in 2009, Northland and North Auckland lost power due to a forklift truck carrying a container that struck 220 kilovolt lines, which was the only line in service at the time. It affected 280,000 people. The Marston Point refinery closed temporarily, and it lost hundreds of thousands of dollars as a consequence of that. And the duration was from 8 o'clock in the morning. So the refinery lost power for 1 hour, Auckland for 2.5 hours, and Northland for 5 hours. On the right-hand side, where the yellow line stops, that's where the Southdown power station was. I think it was open cycle, and the 220 kilovolt line ran through along the water's edge through this shipping container yard. And you can see the risks of a road going basically under the power line. I've just highlighted the masts here, and this road going across here. So anything that runs under this line would pose a risk to the line above. And with these containers stacked high, the forklift lifts do have a reach that high. And the other major effect on electricity infrastructure is natural phenomena like the earthquake. And I've just highlighted some of the damage that was occurred. I have a acknowledgement to where I found this information as the last slide. So you can see, I'm not going to read all these statistics, but you can see the damage was massive, and the picture on the left-hand side really shows how badly the city was affected. You know, the Sumner substation was basically destroyed there, and the other thing was the cables were damaged underground. The same happened to other infrastructure like sewerage pipe and water pipes. PVC pipes tended to heat through the end of T-junctions, whereas PE pipes apparently got stretched and popped out of the ground. So one must include that in your design, but you can never cope with everything that nature can throw to you. There was a fire in 2014 in Penrose. It was also investigated by the Electricity Authority. Early morning, a fire started, I think it was a Sunday morning, and it was due to a failure of a medium voltage power cable owned by Vector, and it ran into the cable duct in the Transpower substation, and 39,000 customers were affected, but they had to switch off power to work on or extinguish the fire. So eventually about over 75,000 people were affected. It was a 1966 vintage cable that started leaking, and someone picked it up. So they've spliced in a new piece of cable, but it was slightly too long, and it had a bowed shape, and the joint failed, and that became an ignition source and caused a fire right inside the substation. Now, neither Transpower, that comes out of the report from the Electricity Authority, Transpower nor Vector identified the trench fire as a risk, and 38 cables, including control cables, were damaged. The picture that I've got on the right-hand bottom here is how the cable layouts were at the time. They started off with many less, but as time goes on, new service had to be added. So the trench was quite full, and from the previous slide, you can see the fire propagated to even cable racks above ground. Then there were several power outages in 2018 caused by gales, and I've just taken this to show how widespread that was, and that's something really difficult to deal with because you have a limited number of crews that can attend to faults, and trees over transmission or distribution lines cause these outages, and some people were out for a week. This is an example. This was not in Auckland. This is a local example of wet soil, and then a very strong wind afterwards that pushed over power lines. So there was another power failure in 2021, and Geoff will talk about that.
Okay, yeah, thanks, Daniel. So probably most people can recall 9th of August last year when the generating capacity available was unable to meet demand, and it caused a Transpower to have to shed load, and that meant dropping about 20,000 homes off the network. That situation hasn't occurred in this country for a long time, and there were a number of contributing factors. There was loss of Te Kanu Power Station due to weeds in the intake. There was an unforecast drop in wind and hence wind generation. There were planned outages with plant out of service. And importantly, there was a lack of pricing signals earlier in the day that caused that would have caused Genesis to start up a third Huntly unit. A Huntly unit takes about 9 hours to start up from cold. And all that kind of conspired with the coldest night of the year, I think it was, and the peak demand of all time on the network. Reading the various documents, Transpower made some errors with the load reduction process. Genesis was blamed by the minister publicly, but then withdrew from that position because the Electricity Authority actually found that Genesis had acted rationally to the pricing signals, and it didn't make sense from a financial point of view to have started the third unit at Huntly earlier in the day. Very costly to start up, and it may not have been needed. So you may, though, all be surprised to know that there is no single entity in New Zealand responsible for security of supply of electricity. Probably we think, well, it should be the Electricity Authority or it should be Transpower, but actually there is no single entity. So to my mind, and there was a good discussion at another seminar put on by Engineering New Zealand this time yesterday, we do actually need some changes to the way the market operates. Currently, there's no fee paid to generating companies just to have large capacity slow start generators on standby. There's no money available to pay for or to incentivize the creation of storage. So I think the ultimate solution here is going to be some changes needing to be made to the way the market operates. these are tweaks on the edge rather than a fundamental rework of the market. That's my opinion. There's some good documentation produced by Transparent Genesis on that subject and the Electricity Authority.
Okay, so what can we learn from all of this?
Right, so just specifically in terms of the Auckland power outage, the 5-week outage back in 1998, you know, as an engineer, I'd like to think that all asset owning entities would actually have asset management plans in place. They'd be monitoring the performance of their assets, be monitoring the provision of the maintenance, they'd be doing risk assessments and so on. So looking back, it was a bit of a surprise that Mercury didn't have that in place for those cables. I continue to find, probably at a lower level, looking at manufacturing companies, it's quite common that asset management plans aren't yet established. My next point is engineers actually understand the risks in infrastructure, but we don't always stand up and insist on being heard. And that's something the profession needs to probably pay more attention to. I watched the Netflix video the other night on the Boeing 737 MAX disaster. There were engineers inside Boeing who knew there were problems with the MACIS system, but they didn't insist on being heard. I'm pretty sure there would have been engineers in Mercury who had concerns, but they didn't stand up and make a point. And as a profession, I think we can be stronger in that role. In a crisis, bringing fresh eyes to develop the solution options. What was really staggering for me with the Mercury outage was arriving with our proposal to build a temporary line and meeting with a group of engineers who hadn't slept for probably a couple of days by that point in time, who were fixated on bringing the cables back into service. So I think when there is a large scale crisis, it's actually bringing in a number of entities, a number of people who can develop options. Those who are right in the middle of it are probably least able to see other possibilities. They're dealing with the immediate. And when you do have a crisis, it's a matter of getting the best people and the best organisations in to execute the recovery plan. And some people would say electricity is priceless. If you think of the damage to the Auckland CBD operation, companies shut down, the damage they were incurring while that was this issue was while the outage continued would have been enormous. So it's not really an issue of trying to find a low cost solution. It's just a matter of finding a solution and bringing in the best people and the best organisations. And you don't wait till you've got the whole solution together. You start putting your executing your recovery plan, but remaining flexible to adapt it as it progresses. And in the case of the Vector, the Mercury temporary line, partway through we were asked to do a tee off to the Liverpool Street substation, which was actually quite easy to accommodate.
Okay, so some other general lessons is ensure that there's redundancy in your system. I will come to that after these slides with an example. Have a system in place to manage the situation when things do go wrong, because things tend to go wrong sometime in the life of an asset. Respond early and accurately to warning signs. Don't push it off and say, oh, we don't think it will happen. The example with a shackle, if they responded earlier on, they could have avoided this whole saga. And as Geoff already said, get outside help. People with other perspectives and vantage points just bring new ideas to the table that with blinkers on, you may not have thought about while the crisis is going. And then formalize requirements and performance levels contractually and audit compliance when outsourcing business critical systems. I think that that point actually came from Dr. Keith Turner, and he said, you know, the contract that was in place to look after the cables were just a few A4 pages, whereas today it would be a thick document with lots of checks and balances to make sure that everything is done, especially to up to a certain standard. And then as people, we need to learn from mistakes and apply those lessons in our future endeavors. There was, I read about this when I did the research, of one person who was involved at Mercury. And although he was blamed in the process, someone said it was not just one person, and the specific person went on and became successful and led companies in New Zealand with great success afterwards. So if you were involved in an incident, it does not spell the end of your career. Just learn from those lessons and apply those and develop your career further. So that's another lesson that I think is important. And then valuable lessons gets lost in history. You know, people Pike River hasn't happened that long ago, but as time goes on, 10 years from now, the high school kids that go through university would probably not think much of what happened there and the lessons we've learned out of that. And as I said earlier, I only became aware of this power outage in Auckland when I bought a little book, 5-Minute MBA by Wayne Brown, after walking through the warehouse one day and saw this little book and got interested and read it. And this cable failure in Auckland and the power failure was mentioned. And then I started asking my colleagues at Opus, where I was working at the time, and they told me about what happened. And so since then, I was very interested about this solution and the vector tunnel. And so one of the reasons why I chose that as a topic today. And these lessons apply to other types of infrastructure too. On the next slide, I will show you an example. And I just want to mention that that same example actually applies to our 3 waters reforms that is in process at the moment, where water treatment plants are going to be centralized and pipelines are going to be built to smaller places. And let me step over. You probably all remember in 2017 there was a failure on the pipeline between the refinery in Marston Point, and the pipeline runs to Wiri, 168 kilos, and it's used for Jet A1 petrol and diesel. The pipe was actually damaged by a digger between 26 and 28 August 2014, when someone was using a very big digger to search for kauri stumps on a unoccupied property. And the person rented the digger from the company who processes the kauri, but then all of a sudden he stopped digging, he didn't cover up the holes, and he left. And the pipe's pressure was increased to give a higher throughput to Auckland. And then 3 years after that, there was this rupture while the pipe was carrying Jet A1, and it took them a while to find out where the leakage was, and it was actually very close to the refinery probably about, I would say about 5 kilos, if that much, from the refinery. And it led to an outage of 10 days. There was no way to load Jet A1 at the refinery, because I only relied to Jet A1 being pumped to Auckland. There was a load-out facility gantry for petrol and diesel, mainly to supply Northland, but the trucks had to come and fill up because the fuel supply in Auckland was severely disrupted for vehicles, and many flights were also disrupted. And sorry, let me go back. So there are 2 pump stations along this pipeline. The one is at Brinderveen, somewhere around this area, I think, and the other one is at Kumu. And there's an example of the pump station, or the picture of the pump station. And this is where the pipe ruptured, and you can see the scraping marks on the side of the pipe where the digger scraped onto the pipe. The guy must have thought, oh, this is a huge piece of kauri, because he didn't want to come out. But I think when he opened it up, he saw he actually damaged the pipe. Now you'll see there's an insulation layer on the outside that's for the cathodic protection, so that they can protect the steel from rusting. So that was broken. And if he just went back to the refinery and just said, I made a mistake, this whole thing could have been avoided, and the knock-on effects was huge. But the bottom line here is there's no redundancy, and yet today there's no redundancy. Geoff, I don't know if you want to add something about what you read the other day.
So I think we now have the refinery is closed, so we're just importing fuel from offshore and into Marsden, and also by sea tanker to other ports around New Zealand. Coinciding with the closing Marsden, the coastal tanker fleet has also been shut down. And so we're entirely dependent, as far as I can see, on offshore tankers going to the various ports around New Zealand to fill them up with diesel, petrol, diesel and petrol, and no secondary solution for aviation fuel. So we've, to my mind, significantly increased the risk to fuel supply in the country. And I'm just wondering which entity does a risk analysis on this sort of thing to fundamental infrastructure, and whether it's actually been properly reviewed.
Thanks.
And probably an add to that, with the Ukraine-Russian conflict and further insecurity of global fuel supplies, have we set ourselves up for a shortfall in fuel at some point in the future?
So I've just included some sources. The slide, or this webinar is being recorded, so you'll be able to access this at a later point. It's really interesting. There are very interesting reading on all the different events. And then the Hobson Street upgrade, where a 3D model is shown on YouTube, is something interesting to look at. It was done by Oricon. And then sorry, that's the questions now. Okay.
Sorry, buttons weren't unclicking on my side there. Thank you both. I appreciate the time you've taken there. And one of the advantages of being the MC is that I get to ask my questions first. So I'm going to ruthlessly take advantage of that, actually. So one of the ones that I've got is it seems to be a recurring theme, and I noticed that Brian Leyland has put the question in here. First of all, how do you persuade the client? It's we can say build the redundancy into our designs, right? And we can say make sure that the maintenance gets done. But how do we actually persuade the clients to make sure that that is done when they are notoriously, in some cases, penny pinching? Any good advice on that one?
Daniel, do you want to start on that one?
Well, I think in the electricity industry, they work on incentives, mainly financial, and I don't think there's enough incentives for people to provide that redundancy, because there's if they don't supply power, there's no consequence for a generator, for instance, if they don't have power. So I think it's a matter of just common sense and thinking what are you supplying and what's your role and your responsibility to the people that you serve.
Yeah, I think I'd add to that the point. There should be asset management plans for all critical infrastructure, factory equipment, and so on. So that's the easy part. How often do the asset management plans get put on the shelf? That's a management failure if that happens. They have to be translated into actual schedules where things get checked, get signed off, and there's senior management oversight that the maintenance routines are being followed through. Once again, a critical part of engineering after the excitement of building something is to make sure that proper maintenance management occurs, that parts are replaced when at the intervals that the supplier recommends, and so on.
Yes, one of the things is, of course, particularly with infrastructure that's hidden, then the maintenance budgets go out the window. And I think that we see that quite a lot in the Three Waters, where in Wellington, where I live, for example, and you have burst pipes and sewage running down the streets because of those sorts of issues.
Yes, we have a problem too with local councils, with elected members, possibly central government, where spending money on maintenance doesn't actually buy votes. Building something new does. So I'll come back to my point that engineers involved in these with these various types of infrastructure have to actually stand up and be counted to make sure that the maintenance is carried out. The politicians are always going to prefer to spend money elsewhere.
Thanks. Okay, so Jake Williams has asked a couple of questions that have been upvoted, and so I'm going to revert to my original promise now and go back to the ones that were upticked the most. So the first question is around the deshackle failure. Did you notice that the accountability model caused any problems with a blame culture arising?
Yeah, actually completely the opposite. The pride that supervisors in particular took in their substations with their staff, making sure they weren't going to be the bearers of bad news and be the recipients of praise for the jobs done, was the way it actually operated. If things still went wrong, but the attitude has to be, let's actually do what we're doing in this seminar. Let's examine what has gone wrong, what are the lessons learned, and how do we modify what we're doing. So I think pride is a very powerful motivator.
And the next question was, what was the biggest thing that kept Mercury Energy from being more responsive after the blackout began?
Yeah, look, they were responsive. You imagine you're the engineering team in a distribution company and you've just had all your cables to the CBD fail a Friday night. They were trying to figure out what to do with this horrendous problem. And I would not call them unresponsive. They were responsive, but they were, I think, too narrowly focused on how do we get these cables back together. And the more hours they went without sleep, the less inclined they were to look elsewhere. So the external provocation to come in with, how about we build you a temporary transmission line up the motorway, was actually rejected. It was actually the CEO with some persuasion from Transpower and the Minister of Electricity who actually gave real momentum to the need for a plan B. So I would never say unresponsive. I would say caught up in a problem too deeply, trying to solve something that was probably not going to be fully solvable in the direction they were going. They just had to get alternative thinking into place.
And the next question we have is, what is the risk of greater than 24-hour outages in the new development areas of Auckland, such as Drury to the south or Red Hills to the west, into the future?
Daniel, I can't answer that question.
Neither can I, because I don't know enough about the networks. So that's probably best put to someone in that distribution area.
And the next upticked one is on the Auckland CBD cable failure. Wasn't the main reason for the subsequent failures the gross overloading of remaining cables as each one failed, i.e. not wanting to do any load shedding?
Yeah, look, absolutely. I think the cables had been running at very high load just routinely for a long time. The solution to the growing problem was to build the tunnel and bring a new supply into the CBD, but that hadn't actually got up to the Mercury boardroom for approval, or if it had, it hadn't been approved. So as each cable failed, the decision seemed to be to take more load onto the remaining cables while they probably tried to get the failed cable back up and running. And with hindsight, we can see there were some other things that could have been done operationally that could have potentially avoided this problem by shedding load.
And Brian Leyland has put on a comment here saying one of the lessons of the CBD failure is that if a cable dries out, it's doomed. Yes,
exactly. So Brian knows more about this than I do, but I think when the gas-filled cables were installed, the local engineers said they didn't need supervision from the supplier from offshore, and the material that was used to backfill the trenches around the cables didn't have the thermal conductivity needed to dispense the heat being generated by the cable when the ground warmed up. So Brian's absolutely right with his comment there. A failure I've been involved with was over in the Bay of Plenty, and the generator cables were installed. Oh, this is a little geothermal power station in Kawerau. The generator cables were buried according to the local utilities requirements in pumice, and the cables have been sized and so on based on the utilities specifications. What everybody had forgotten was that generators run full-time, full load, which means whereas the utility, the distribution company, has its morning peak and its evening peak, and the demand varies during the day. So there's time for cooling. In this case, no time for cooling. And so that was a Christmas phone call I got to say that the cables that the company I was managing at the time, the cables that had been installed had just melted. but it turned out that the job had been done to the power board specification, and the specification was inappropriate for generator cables.
Yeah, Brian has commented on here that the original cables were supervised, I think, but the problem was with the aluminium sheets, and that the second failure was within its calculated capacity, but the conductors expanded and the joints failed. As I think you said in the presentation, it was the connections that dropped out.
Yeah. Hey, look, Brian has got much more knowledge about the failure mode. I was really on the recovery side rather than the original cables.
And one last comment, which is, it's more of a comment than, and it's not directly related, but it is sort of working within the redundancies, was water reform will allow for increased security of supplies rather than standalone supply from within a council area, and increase available expertise within the 4 entities rather than being spread around amongst 60.
Daniel, any thoughts there?
Well, I'm just pointing out that the lessons that we've seen here can be applied to the infrastructure that's being developed. And if you have a pipeline, say from Palmerston North to Leuven, and there's a seismic event that damages that single pipeline, for instance, then there would be no other alternative than to cart the water by vehicle. So I'm just pointing out that we should think about the bigger picture and some form of redundancy, so that if one thing fails, that you're not sitting in a situation where you cannot supply something to support life.
Completely agree. I'm a big fan of having water to drink. And I think we'll make this one the last question, actually. Would it help if the Official Information Act were extended to include all lifeline utilities?
I wonder if it already does actually cover that, but I think it's a really good point. Who actually looks to make sure that we avoid crises of some of the types that we've just been talking about? How do we know that companies or local government, central government entities that have responsibility for security of supply of various services are actually doing the job? It's all a bit vague for some of those. When we're talking about water, Wellington Water has been in the news, well, for a variety of reasons, most recently for the failure of fluoridation plant, which had to be a surprise to most people. How could that have continued for, I think, for over a year? And we go to what kind of boards do some of these entities have? Is there enough technical expertise on the board? Is the engineering profession appropriately represented on boards of, let's call it engineering or infrastructure owning entities? So I guess I'm asking questions rather than providing an answer. But again, I think the engineering profession can see should be seeing members having some more significant roles at higher levels and entities in the future to make sure the entities deal with these issues.
Yeah, I agree. It's interesting. I was, as you probably know, at Engineering New Zealand, we've got all of the back catalogues of the old IPENS books that came out annually. And someone said that in the 1970s, there was someone stood up and said, engineers aren't being, we don't have the respect that we deserve, and we're not being listened to, and so on. And that was pulled out as a quote a couple of years ago, and everybody basically agreed to it as if it was a new thing. I was having a look in that library a couple of months ago and found exactly the same quote being pulled out from 1946 or 7, I think it was, in one of the books from then. This isn't a new thing for us. We've been grappling with how to get the engineer's voice heard across organisations and institutions for a long time. And if anybody's got any good ideas on that, I'd love to hear about it. Because nothing's really changed in the last 80 years that I can see of anyway, with getting engineers up into those positions. So, and on that, I'll leave us on that note. And so, look, thank you very much. I really appreciate the time and effort that you've both put into the presentation. And the next Lessons to be Learned webinar will be coming on in a month. It's going to be with the New Zealand Concrete Society. It's going to be Adam Leach on Thursday, the 5th of May. And more of the details will be available on the Engineering New Zealand website a little bit closer to the date. And we'll leave you with that one. Thank you very much, and enjoy the rest of your day.